I'm going to spare him having to turn red while we talk about his illustrious career. But of course, our guest this week is the one and only Jim Keller, current CEO of Tenstorrent, co-founder of Atomic Semi, whose notable work includes, and brace yourselves because this is a bit of a list. He was the lead architect of the AMD K8 microarchitecture and co-designed the x86-64 instruction set. He was later the lead designer on the Zen architecture that catapulted AMD back to relevance and now more than. He helped design the Apple A4 and A5, the company's first in-house SoC. He's the former VP of Autopilot hardware engineering at Tesla more recently. He left Intel in 2020 following a dispute. We don't need to get into the exact details of that, but joined Tenstorrent as CTO the same year and became CEO in January of 2023. In 2023, he also co-founded Atomic Semi, a foundry that's focused on designing and manufacturing low-cost fabrication equipment, which is something I have to admit had flown under my radar, and I'm definitely going to want to ask a little bit more about. And without further ado, thank you for coming on the show. There he is. Hey, thank you so much and welcome.
I'm struggling to impedance match your enthusiasm. Pretty good.
I think we all do. It's okay.
Realistically, look, I usually have to sell it a little, but I am genuinely extremely excited to have you on the show. They asked me when I got on the phone with your team because we reached out when we saw the dev kit that you guys have right now. So this is on the Tenstorrent side. And I was like, okay, obviously, whatever Jim's working on is probably cool as shit. So maybe there's something here. And so I scheduled a call. It's just exploratory call. And they go, oh, well, do you want to talk to Jim? And I'm like, well, we don't really take guests on our show anymore, but yes.
We'll make an exception.
That would be great.
Wow.
I don't want to waste anyone's time, which is actually a big part of the reason we don't take guests. We are notorious for starting our show anywhere from 1 to 3 hours late. And we hate doing that to important people. So without further ado, I want to get into some of the community submitted questions. We announced that you were going to be joining us, and it would have been a huge disappointment if you weren't here, but you are. So Dylan asks, hey Jim, I'm a junior computer engineering student about to start my first internship doing verification engineering at a big chimp company. First of all, did I just say chimp company? Anywho, doesn't matter. The point is, congratulations, Dylan. He says, it's great to see how far open source has gone. We even learn RISC-V in our introductory hardware course.
Oh, cool.
So first of all, I want to start with letting you talk about RISC-V a little bit because that's obviously a hugely important part of what Tenstorrent is doing right now. And I guess I realized I didn't really talk about Tenstorrent at all. So do you want to give us a short introduction to what exactly drew you to this company and to their mission?
Wow. Okay. So Tenstorrent is an AI computer design company. We're designing a high-end AI engine and also a high-end RISC-V processor. And I think, AI has gone through a lot of evolution. And, it started running on CPUs and then GPUs. And then I think Google announced the Tensor processor in 2015. And we're building essentially an array of Tensor processors that's programmable with open source software stack that we released in January. And then there's going to be a combination of AI computing and general purpose computing tied together. And we decided to make a high-end RISC-V processor. Our AI processor also uses little RISC-V cores, to drive the execution of the big Tensor processor.
So
the RISC-V thing is really interesting because, at some level, computer architectures are generic. It doesn't really matter very much if it's x86, PowerPC, MIPS, Alpha, ARM, or RISC-V, but only RISC-V is open. And the Berkeley guys that started it were pretty good. And the cool thing about open source, as we saw with Linux, is when it's open source, a whole bunch of people can work on it. It's a much better innovation platform. And it's a one-way door. When people go from, proprietary technology to open source, they literally never go back. Linux killed literally all the proprietary Unix operating systems. And I think solely RISC-V is going to take over the computing world. which is pretty fun.
Just want to say,
to your student friends, go ahead.
I was just going to say, if I'm one of those Berkeley guys, I'm putting Jim Keller said I'm pretty good on my LinkedIn. Like immediately. That's
Yeah,
awesome.
they're pretty good. Well, yeah, I could tell funny stories about computer science in universities and computer science in high-end computer design companies. They kind of work together, and it's really interesting because a team of 100 people work together for 5 years can refine the crap out of something. Whereas students, they get a project, and sometimes without that much support. And some of those projects are pretty good, and some of them, it's hard for it to add up to a lot, let's say.
So
But like the branch predictors everybody uses came out of universities. And the RISC-V architecture, which is going to, let's say, dominate computing in 10 years, came out of universities. And now there's 20-odd companies building RISC-V computers and way more using it. So
whether you did it on
wild
purpose
phenomenon.
or whether you did it by accident, you actually transitioned me perfectly into the second half of Dylan's question. And this is really cool because he asked for getting into a higher level architect/designer position. If you want to work on one of those teams, are you going to recommend stay in school, go for the PhD, or do you want years in industry? What are you looking for?
So PhDs are really good for some people if you really have a research topic and you really want to go think really hard. But if you want, I didn't study computer design in college. I'm an electrical engineer. My major was first electromagnetic fields, and then when my advisor ran the semiconductor physics lab, so I learned a lot about that. And then I took one logic design course, and then got a job doing that, and then I got a job at Digital, where I worked for a great architect, Bob Stewart. And then computer architects, good ones, know about a lot of different things. So I learned how to program, do logic design. I know about semiconductor physics. I know a weird amount about packaging and signal integrity and all kind of stuff. And so if you want to be a computer architect, you should probably work on a lot of different things. And most computer architects that are really good at it didn't do it in college, as a PhD. Interestingly enough, it's almost like a too narrow of a way to go about it. PhD guys tend to be experts in something. And
that makes sense.
Computer architects tend to be generalists, I'd say.
Yeah.
So you already kind of alluded to this one as well, but William asks, you've obviously got experience on the ARM side. You've got experience on the x86 side. You've got experience on the RISC-V side. William asks, how far do you think x86 64 can go? You're telling me now, you're saying, look, RISC-V is going to be the future. You gave that number 10 years. I'm not going to hold you to it. I can't promise nobody else will, but I'm not going to hold you to it. Is that because x86 is out of gas, or is it because RISC-V has just got some kind of fuel that we're only just discovering the potential for in the engine? Which one is it?
Neither. So computers generically, they fetch instructions, decode them, and issue them, right? And the thing that makes the front end of a computer fast is how many instructions can you decode and how well can you predict the instruction stream, right? So x86 has a deficit in the sense that, random length instructions are harder to predict, but we sort of figured that out. It's just harder to do, but it's not like a big limitation. And then the execution engine goes fast because you have lots of parallel execution units in out-of-order issue, which is generic to computers. And then you have a good memory system with a really good predictor for where the data is coming from, which has nothing to do with the architecture. So I'd say x86 has a limitation. So it's 16 registers, variable length instruction set, and it sort of has a pile of old crud that nobody actually needs, but you have to build. So it has a tax.
Right.
But computer performance is mostly today based on prediction. And the number of predictors in a modern computer is crazy. We predict, obviously, where the instruction stream's coming from, where the next branch is, the direction of the branch, call return stack. We predict the width and grouping of instructions. We sometimes predict the results of instructions.
So tell me this.
Where the data is coming from. So it's all prediction.
One of the, a follow-up question from William is, could we see cores using multiple architectures? Could you see someone like an Intel or an AMD, an x86 license holder, taking some kind of RISC-V architecture, AI processor, coprocessor, and using that for prediction? Like an AI accelerant on a traditional, does it just not make any sense? I mean, tell me. If it's a dumb question, I'd love to know.
Yeah, it probably doesn't make very much sense. So computers are very optimized to run a particular instruction set. Today, there's pretty good binary translators, and they keep getting better. And binary translation from like an ARM instruction set to RISC-V is relatively easy and back and forth. So you'll probably pick your general purpose computing architecture and then either recompile all the code or translate the code you need. Like Apple switched from x86 architecture to ARM architecture. They hardly missed a beat. Nobody even noticed or cared. And
that's
some
great.
of that's the Apple ecosystem and software build. But they could switch to RISC-V and nobody would notice or care either.
This is hilarious. He keeps beating me to what my next thing is going to be. And it's all prediction, right? So I just don't even. Why do I bother talking?
Well, we live in a simulation, and a good simulator predicts everything. And
so the next thing I was going to.
The way it is.
The next thing from William's question that I was going to focus on. So he asked, okay, how far will x86 go? Do you think ARM or RISC-V will replace it in the future? Maybe we'll see using multiple architectures. So that's all William's questions so far. I'm not taking any credit for that or blame. But what I will take credit or blame for is this next one. I was really focused on the word replace in his question. And you brought up needing to recompile code. And software is something that I feel like is a bit of an elephant in the room, when you talk about how, well, fundamentally all processors are the same. Essentially, it's like how many instructions can you process? But while Rosetta 2 was an absolute marvel, to the point where just a few years ago, I wouldn't have even shortlisted William's question, let alone asked it to you. But now that I've seen what Apple was able to do with that x86 to ARM transition, and what Qualcomm is claiming that they're doing on their upcoming Snapdragon chips with Windows on ARM, I feel like anything's possible. And that word, that replace word, can I expect to go back to legacy programs, right? To stuff that is that tax on x86, that tax on Windows, and whether it's through AI or whether it's through on-the-fly recompiling, can I expect to replace the gaming PC that I have today with something RISC-V that will run? And I'm not going to ask for 100%, but if I asked for 90% of the software I used to run, do you foresee that?
Yeah. Of course.
Of course.
So more and more software is written in higher level languages, like recompiling C programs in Java and Python and you name it. It's getting easier and easier. Like the architecture mostly doesn't matter. Now, what matters is on a given architecture. Like we found this. We started building like a server stack for RISC-V, and when they went from Intel to AMD to ARM to RISC-V, each time you port software, it gets easier to do. And the hardest port, by the way, was Intel to AMD, even though they're both x86, right?
Really?
And that's because there's a whole bunch of proprietary software in the server stack that was actually Intel proprietary. So you weren't, which, by the way, they weren't giving out the port. So they had to rewrite a bunch of stuff, but all the new software is in C, C++, it's clean. So porting to ARM was easier. Right, porting the RISC-V is pretty easy. The thing you find is like the toolchain maturity, like somebody built a binary with some set of switches, and then you link that, and somebody mislabeled one of the header files, and then you have to be an expert to figure out why this thing didn't work. But the actual porting of the software is not the hard part.
Can I interject?
And RISC-V's ecosystem uses GCC and LLVM, and they're really mature compilers. Like they literally use the same compilers on the back end for all the architectures.
You mentioned there the server stack for RISC-V. That's a huge deal, and I know there was the struggles with the Intel to AMD transition, and that hampered AMD a bunch of stuff. It's going to be a big problem solving the server stack thing. How's that going? I know you guys are working on it. I know some other companies are working on it.
Yeah, it's going pretty good. So, and again, this is one of those. So Amazon did a really fun thing. So in AWS, they put Graviton in there.
Yep.
And first they ported some of their own applications. So, and Amazon's pretty good at putting a gun to somebody's head and saying, you will go, port the software and get it running. And then they said, yes, sir. And they did, but then they put it up on the web and said, hey, if you want to, port your stuff to ARM, it's 30% cheaper, whatever the number was. And a lot of people said, sure, that's easy. It's JavaScript anyway, who cares? Right? And so people started porting it, and the more people ported, the better it got. And it's easy to tell if the application, and they made it pretty generic. So I think what you'll see is like heterogeneous data system. So you have a cloud, and there'll be some Intel servers for the dinosaur code, and then there'll be ARM and RISC-V for stuff that's already been ported, and there'll be a price difference, and then people will go, where they need to.
Keep converting.
Like nobody cares about IBM 360 code or VAX code or Sun code or HPUX code. Like it's all gone. And you won't care about the games that you ran 10 years ago because there'll be better games. They'll just emulate them or they'll AI emulate them. Like that'll be the really funny thing. You'll say, hey, I want to go play Super Mario Brothers, and you'll talk to a computer and describe Super Mario Brothers and play a little video of YouTube video from the 80s, that played Super Mario Brothers, and it'll emulate the whole thing, and you'll think it's fine.
That's kind of terrifying. I can tell you there's a lot of gamers watching this right now that are going to be really unhappy about that. But we're going to move on.
No,
guys.
Some of them could be really happy because now they have these games that are going to get Pong from this, the 80s and shit. And they'll be able to train an AI engine to play perfectly.
Nintendo's litigating really already.
Like Space Invaders, all the stuff that we used to play at bars.
I can hear Nintendo's lawyers from here.
Yeah.
Carol asks, as a junior IC design engineer, I often wonder how to stay on the bleeding edge in the semiconductor industry. Recently, I discovered Intel PowerVia entirely accidentally through a YouTube video and blamed myself for missing it for almost a year. What is your advice for keeping up with the industry besides just, creating new technology yourself?
Make sure you work someplace where they're doing new stuff.
Wow. Okay.
So what happens?
This is a recruitment interview now.
A lot of places. Yeah,
they are hiring.
Sure, we are hiring. No, so you build a technology like a CPU, and at first it's new, and it's got a lot of problems, and then you start refining. They get pretty good at it, and then the management teams typically go, well, it's really risky and expensive to do a new one. What if it's worse, right? And you start refining, and what happens is people get in smaller and smaller boxes. Whereas when you do new projects with like a new team, everybody does a little bit of everything, and you have to go solve new challenges. And when you do a new project, you never use an old CAD tool, or you sort of aim forward. Whereas I was at Tesla and we talked to vendors of a bunch of our chips, and half of them couldn't do a small tweak to the chips they had in production. They've been shipping them for a couple of years.
Well, was it the knowledge that was
missing?
missing?
They didn't have the CAD tools. No, they had the database to run it on the fab, but they couldn't update it, right? And it was so if you're a young engineer, make sure you're working someplace where they're doing new stuff. There's lots of new stuff going on.
You did it again. You led me right into my next question. This one's from me, so again, I get full credit or blame if it's a stupid question. I've always wondered this. In my layperson brain, looks at a new innovation, a new generation of chip, whether it's from an Intel, an NVIDIA, a Tenstorrent, whoever, right? And I look at it and I go, okay, but really tell me this idea you guys implemented, where did it come from? How much of that generational improvement is A, we didn't think of it before, versus B, we needed to try it first, but we went small before committing big, versus we totally thought of it, we totally knew it was a good idea, but the process node technology, for example, didn't allow it. We had other priorities. Like, how much of it is A, B, or C? I want to know, right? Like 3D Vcache, I think is an...
It's all of them. Yeah,
okay.
it's really weird. So, I mean, in the Platonic reality, everything already exists, right? So we don't actually live in that world. There's literally an infinite number of possibilities. Most of them are bad, right? And so...
Thanks, Dr.
No,
Strange.
it's true. It's
Yeah.
So that's a problem. So there's one thing, which is you work out a bunch of, you're making a new CPU. You have a bunch of ideas. You say, these are really solid, but I want to make it, say, wider issue. But that causes you to have to go rebuild the entire cache and fetch system. And then the more instructions you fetch, the better your predictors have to be. And some predictors scale just by making them bigger. But sometimes you need a better algorithm. Like the simple branch predictors we started with were fine for years. But if you're trying to keep 500 instructions in a reorder buffer and never flush the pipe, it has to be so accurate, it's unbelievable. Now, some of those things were invented. Now, here's a funny story, which is Intel ran a competition for the best branch predictor. They published the results, and one of them was in Wikipedia. And when we first started doing Zen, we needed a really good branch predictor. So I looked it up in Wikipedia, flew over to meet the guy, and paid him for a patent. You can't make this shit up. Now, the mathematical... So it turns out there's math under these kinds of predictors, which is a little related to how neural networks and AI work, right? And so the initial predictors was sort of do what you did last time, and then the better version was keep more track of the history of what you did before,
right,
and use that. But at some point, it started to look more like a computation of, there's this space of paths in the program, and can you compress that space of paths to something useful, and then predict which path you should follow on, which is related to a field of mathematics. And then it wasn't really possible until you had enough transistors. So Moore's law gives you more transistors every couple of years. And so there's this and then there's a trade-off. Like in the short run, maybe I'll make this bigger because it's easy. But I can't just keep making it bigger, so I need to find a better idea or do something sophisticated, and then take advantage of all the transistors. Like it's a combination of things. And then every time you build a computer, you'll learn a lot about doing it. You continue the performance model, software continues to evolve. And there's some things that used to be a bad idea that are now a good idea, and vice versa. So it's complicated.
Let's shift our focus.
And there's lots of published stuff, like people don't realize how much information's out there. There's 100,000 people building faster computers.
Let's shift our focus.
Some people know a lot about what's going on. Yeah, go ahead.
To AI, because obviously that's your next big challenge that you're taking on right now, and I've got actually a number of different. You know what? I'll go with one of the ones from our audience. I've got kind of an adder to this one. Charles asks, AI is set to disrupt the global economy in ways that we've never experienced before. Not in our lifetimes, maybe never, ever as a species. What do you see as your role in guiding an economic future that includes AI? And then my follow-on here is, as a key contributor, potentially, to this upcoming change, do you feel a personal responsibility for shepherding AI in a responsible direction, or do you kind of go, well, look, that's the software guy's problem. I just build the platform that it rides on. Like, what's going on here in your mind?
Well, if you're a historian, the human race has been radically disrupted, a dozen times in the last couple hundred years. Automation is kind of wild. My father used to tell me it was the fractional horsepower motor that automated all the factories. Electricity generation was huge. Everybody talks about the printing press, books, being able to read, college educations, highway system. It's a lot, right? And then Kurzweil says, progress accelerates. And so it's one thing for something to happen like once a generation, but we've gone through mainframe in a computer workstation, PC, mobile, internet,
yeah.
Cloud computing, always on, always connected. And
a lot of that's in my lifetime, man. Like, what is going on?
this is a lot of accelerations in one place, right? Now, I'm a technologist. I know how to build computers. And my part of it is, I really don't think the world would be a good place if only the super rich corporations had big computers, right? I think AI technology should be available to as many people as possible, that the software should be as open as possible. I really like the fact that some people are publishing really good AI models. We decided to publish our compiler stack. As you know, like the core of the TPU compiler NVIDIA stuff is proprietary and not accessible to everybody. In terms of managing society, I don't believe individuals are the right answer to that. I think this is a collective effort, which needs a lot of people to think about it. Also, but on the flip side, in most of the transitions we've ever had, the doomsayers have been wrong. Right? We keep solving how does society and people and individuals work together to solve our technology problems and the balance of power between all the factions. So I have some concern about it. I have a belief in human progress. I think I like the open source world. I like open technology. I like products that people can build and afford. I'm not really into the $1 trillion computers that only 2 people can afford. So my Tenstorrent's mission is partly like, how do we make computers cheaper and how do we make them more open? And when we're licensing our technology to a bunch of people to build their own products. And I think that's part of the democratization, I'd say, of AI and software in general, which I'm a fan of.
So tell me this. I mean, AI is clearly it's in that stage right now. It's like it's a toddler, right? Like it'll do something one day that impresses the hell out of you, and then it'll be, running to greet you when you come home, and it'll trip and nail its face on the floor, and it's got a big nosebleed, the 5 minutes later, right? Like it's clearly stumbling around, looking for its footing, but you see the potential, right? You see what this thing's going to grow up into. How harmful do you feel like high visibility AI fails are? The humane pin, for example, is something that we're going to be talking about later on in the show, has generated a ton of mainstream buzz. And I mean, that's obviously, there's some recency bias there that makes me bring up that versus, talking about some of the, like the $30 million heist that was facilitated by machine learning powered deep fakes. There's clearly a lot of FUD around AI. And do you think that sort of damages our progress in the long term, or is it all just a blip?
Yeah, it's all a blip. Like AI has already been through several hype cycles. It's going to go through more hype cycles. The history is usually the big first movers don't become incumbents. Like nobody heard of Google and Facebook and Amazon before they became big. It was IBM, Digital Equipment, Sun Microsystems. They're all gone. So, there's going to be multiple blips. There's going to be, both funny and, somewhat scary, issues. But it's, the human race is pretty big and resilient, and there's lots and lots of smart people. And, it's going to elaborate out all over the place. It's happening as we speak. Am I worried about it? I am definitely curious. It's going to be a wild ride.
Okay, you did it
like
again.
The last 25 years have been wild.
You actually did it again. Are you sure we're not in a simulation? Because the next thing I was going to ask is...
No. Here's the really funny part.
Okay, here we go.
If you were going to build a simulation, you would build in a bunch of things that, let's say, limit the computation you need. Like the speed of light's cool because you can't really see what's going on over there because there's a limit to, things don't interact all at once. And the uncertainty principle is really cool because when you look at something really closely, it gets a little bit undefined. We live in Here's my favorite part of the universe. We live in a universe that's governed by three principles: the uncertainty principle, the incompleteness theory, and the unprovability problem. So it's uncertain, incomplete, and unprovable. If you were building a simulation, those would be some pretty good rules to put into it, because that would massively limit the amount of computation you have to do.
Okay, so what I was going to bug you with then is, I mean, NVIDIA very publicly, very loudly dropped 10% of their valuation today. And every time, right, every time something like this happens, you get people on both sides going, no, it's real to the moon. You get people on the other side going, it was a bubble. They're talking whether it's .com bubble or whether it's Web 3.0, or they're pointing at some other hype bubble. What is...
All companies are bubbles.
Yeah, can both of those things be true, was my question.
Yeah, that's capitalism. Somebody said, oh, that company's just kicking the can down the road. And somebody else said, duh, that's how companies work. Right?
So what does
you get
stability...
investor dollars, there's no stability.
Okay, there's no stability. Okay, then...
Well, there's a dynamic stability in the sense that there will always be 100 top companies. But those companies change continuously. Like the myth is, the super rich will always be rich. That's mostly not true. The super big companies will always be big. That's not true. Like, there's virtually no companies that are 100 years old that are still viable.
Speaking
so everybody's got their day in the sun. So
okay, speaking of which,
changing.
You're at the helm of a company now. My understanding is this is your first time in the CEO position. Is that correct?
It is.
Okay, so I was going to ask you, with that knowledge, right? Like one of the really famous quotes from someone, I can't remember who because I'm terrible at names, but a really famous quote that I read at one point was that good leaders lead a company, great leaders put the company on a path such that when they leave, it becomes better than it was with their leadership. And you just said it, right? Like, there's very few companies that are 100.
Like wishful thinking. Yeah.
Sure. Okay, but well, hold on. Let me finish the question before you predict my whole thing and answer it. So, knowing that 100 years is an awful long time for a single company to stay viable, what does your leadership look like? Is it an in the trenches leadership? Is it a set the vision and let people do it leadership? How are you finding it?
Well, yeah, I'd say I like to do both. I like visionary leaders. I worked in Steve Jobs' Apple, and I worked for Elon, and I learned a lot from those guys. They are both visionary leaders, but they're also really hands-on people. Like, Steve Jobs worked on products every day. Now, he didn't work directly with that many people, but I worked for a guy. I talked to him literally a couple times a day, Mike Colbert, who's a brilliant guy. And it was very hands-on and very knowledgeable about everything we were doing. And, and Elon's the same way. It's like he's a wonder in terms of how many different technologies and stuff he can say useful things and have insights about, and he likes everybody to be hands-on. So, yeah, I'm into the hands-on thing. So now, I'm a believer in what's called collective creativity, and I like people to own stuff and feel empowered to go do it. I played the "fuck around to find out" video for my whole company on an all-hands meeting. And, it was fun, and that's so I like people to get stuff done, and but also to own it, and it's okay to screw it up and fail, and as long as you learn something and try it. So it's complicated to be a leader. If you just tell people what to do, they don't do a very good job. If you just pay attention to vision, that's not enough. You have to be ready to willing to work with people and find people like good people that work for me. I have some really good technical and organizational managers, and they're pretty hands-on people. They know what they're doing, but they also know how to give people space to go do something useful. And it's a combination of things. You got to do both. Okay, well, tell me what success looks like. For Tenstorrent? Yeah. Every year we get to build better computers, and we build products our customers like, and we keep going. So here's a funny one. So when I was at Digital, we used to joke that we'd build computers till the money ran out, and then the money ran out, and we went bankrupt. So I went to AMD, and I told somebody that joke, and they said, Jesus, the money runs out here all the time. We've been bankrupt like 3 times. Jerry Sanders just, he goes borrows some money or cuts a big deal. So like running out of money was not an AMD problem. And when I went back to AMD, we were like months from bankruptcy. And Jensen's famous for telling everybody they'll be bankrupt in a month, for most of the company's life. And so, no, like you build stuff. As Steve Jobs said, you're only as good as your next product. Right, I believe that. Like people build a great product and you think, now we made it. Not in technology. No, you go make a better product. Or the market changes, or the customers want something different, or you'll learn something new, or somebody else learns something new that you didn't know about. So yeah, success for me is, I want a team that's, engaged and interesting, and we're building useful stuff, and we build stuff that somebody wants. And then my expectation is we'll have to go build something else. Like, keep going.
Of course, we were going to have some questions about your time at AMD. Hector asks, you returned during a challenging time, which you've alluded to just now. What was the morale like? Was it fight?
Bad.
Was it flight?
Resignation.
Ooh, apathy.
Yeah, so when I joined
worst.
there, so I'd worked at AMD. I liked like when I was in AMD in 98, 99, something like that. I liked the culture of, it's a teamwork culture. Apple was much more of a hard edge, do the best, excellence, reward the top kind of culture. So I was intrigued. I thought they were going bankrupt when I joined. It was closer than I thought. They had fired 1/3 of the people. I think we ultimately laid off over half the company. But the people that were there liked each other. The expression, the rats leave the sinking ship? There weren't many rats at AMD when I got there. They'd all left. And the people that were there were often technically very good, and they were good to work with. So, and I thought it would be fun to figure out how to turn the company around.
Yeah,
if it didn't work, like I'd just get another job. It's like I wasn't really worried about jobs. So I went in there sort of knowing, what's going on. There were some things that, to be honest, were worse than I thought.
Yeah, nobody
like
talks about the rat that voluntarily swims back to the sinking ship. So put us in your put us in your head.
What you're trying to say?
Yeah, well, I call a spade a spade.
Well, I was friends with Mark Papermaster, and I said I wanted to lead the CPU team, and they wanted me to be the architect. And I thought I could never pull this off if I'm the architect and somebody else manages the people, because building a great product takes a combination of architecture, teamwork, organization, all kinds of stuff. And I hadn't managed like 500 people before, but I read a book about it. It's not that hard. Actually, to be honest, I read 10 books about it. I hired a consultant who was excellent about this kind of stuff.
Okay, so it's a little bit hard then.
Yeah, 10 books. Took a couple of weeks.
Right,
it was really fun. And then, Rory Reed was CEO at the time, and I told him I had to cancel all the projects and start over. And he's like, "Yeah, nobody cares if we have like 50% of the competition or 53, and go ahead and do it." So I had a lot of freedom, and then a lot of people had a lot of good ideas. It wasn't just me. So we kind of unlocked it, and I'd say a lot of people didn't believe in the product. Some of them didn't believe it right till it was finished.
Really?
Because they were so used to AMD losing. Yeah.
Well, hold on a second. How does that happen? Okay, this is something that maybe does not speak...
Engineers are very determined people. They can work on something they know is never going to work, but they're having fun doing their part, and they just soldier on. It's
okay, but hold on a second. And maybe this isn't your problem, because, you can tell just from the blunt honesty that you haven't spent a day in marketing in your life. But
I'm great at marketing. I can sell you your own shirt. That's a book about it. It's not that hard. Yeah.
Okay, but help me out here, because this is something that blows my mind, is a product will arrive, and us monkeys who basically are just like, I don't know, run game, measure frames per second, are sitting here going, hey guys, you got the pricing way wrong. You're at 80% of the competition and you're priced 20% higher. And you get people who presumably talk to people who worked on the bloody thing and they're like, oh, really? And you just kind of go, where does this disconnect come from? How could you possibly be, help me with this, how could you possibly be an architect or someone working on Zen? You got your nose right up against this thing and you go, I don't know, maybe this thing's shit, I have no idea. How does that happen? How can we tell and they can't?
I'm sorry, what question you're asking?
Okay, the question you're saying, some of the people working on Zen up until the very end, you go, yeah, they didn't believe in it. How's that even possible? Because they'd
worked on the previous product that wasn't any good, and they just assumed this wouldn't be it. I don't know.
But they got the
I would
same.
tell people what we're doing, and they would look at me like, Jim, we could never do that. We're not that good, or something. I don't know. So here's a funny thing. So a friend of mine told me this years ago. So every company will tell you, we only hire the best. We're the smartest people in the world. And what he said is at 100 people, you can have a really excellent group. And at 1,000 people, you can be above average. And at 10,000, all companies are average. It's true, just by statistics. Now, there's a question about whether you lead from the top or the middle. There's a bunch of management theories about this. And then there's a lot of problems with how you do things, and then there's this risk reward. If you have an okay design and you want to make it 10% better, it might be really hard. But if you do a new design, you aim for 30% better, you can do it. But the risk of that's way higher. And so people make bad risk reward trade-offs. The existential risk of being 50% the performance of your competition was 100%. And yet they were doing low risk 5% moves.
Right.
So we said, hey, let's build Zen to be just as fast as, we started out, I said, we'll beat Haswell, which was a processor competition at the time, and which, by the way, was shooting behind the duck a little bit because we assumed Intel would keep moving. But
that was my next question, was how much did Intel
which was handy.
Save AMD by just stagnating like that? I mean,
50%.
Okay, that's 50%. A lot. Now,
you need a good design. Hey, and somebody said, he always told me I did not bet on luck enough, because I do what I can and I assume everybody else is doing what they can, but I didn't see that coming. So I think that was pretty handy for them.
Yeah, a little bit. And, so tell me right now.
But it was a good design and it was clean. So one of the things people don't realize is when we built Zen, we had a pretty clean architecture and redid the CAD tools, the methodologies, the flows and stuff. And then, Zen 1, 2, 3, 4, they were able to make pretty good progress. Then what happens is at some point progress starts to slow down because you really need to do either a from scratch or a big rewrite, and then, to get on the next curve. And that's one of those complicated things.
Now tell me this. Right now, realistically, the 800-pound gorilla in this space is not Intel. It's NVIDIA. Or unless you disagree, in which case I'd love to hear about it. Okay, good. So we're on the same page there.
And it's still founder-led, and Jensen is a really smart guy. So
it's
not only
Are you shooting behind the duck? Are you shooting ahead of the duck? What are you guys targeting? Because you're trying to disrupt NVIDIA, essentially, if I'm not mistaken.
No,
you're
I don't
not.
care about NVIDIA.
Okay, then tell me what duck you're aiming at.
There's so many. AI is a huge market. NVIDIA builds very expensive, very high performance, very high power products that people like, right? With very high gross margins. Turns out there's a big market for smaller AI engines, open source software, licensable IP, chips they can buy and put in their own products. That's not $100 billion market. I don't need that. I'd die and go to heaven at $500 million in revenue. So I'm building products for other people. Now, some of our products I think are really effective, and we'll see. But it's going to take a while to do that. And I have literally more business right now than I can deal with. And we're working on delivering hardware and software, and we'll see what happens. Now, And then the other piece is, I think the AI revolution's just started from a computer architecture point of view. And also there's going to be an interesting revolution in how we build general purpose computing. So one thing I want to do, this is personally, is I want a really good AI and CPU design that I can then iterate on as software and models and a whole bunch of things change. And so we design with conscious intent. Like our AI engine is clean and simple, right? Our software stack, you can go read it yourself, right? It's pretty straightforward. We're getting really good performance on it. And we have a whole bunch of stuff coming in the next 6 months that raises the bar on it. But if we had to say, hey, there's this new model, go rewrite the software, I don't have 2,000 people with 20 years of technical debt of software. I have 100 great people writing software, and the software stack's clean. And same with the CPU. Our RISC-V CPU it's going to be super fast, but it's a brand new design with brand new architecture, and it's really clean. And if we want to, radically change it, I could do it. I'm not stuck because, somebody's CPU that's been iterated on for 10 years, where 3/4 of the code was written by people who don't even work there anymore. Like we own our own stuff, which is pretty fun.
So,
I'll give you a funny example. So everybody told me, especially there was a big debate about autonomous driving. Should it be driven by a C program that makes the decisions or an AI model? And the assumption was the AI model is this murky, thing that inputs go in and outputs come out, and you don't know what the AI code's doing. And they had it exactly wrong. The C program was 5 billion lines of code written by 100 people over 5 years. They had no idea how that C program worked. But the weird part is it doesn't have a proper loss function. Whereas the AI model, you trained it with a known data set, and when you train it, you know exactly what its error properties are. So which one's better? The AI model you built yesterday from scratch with a known data set with a known error function? Or the C program written by a whole bunch of people over time that nobody knows how it works? I don't know. So one of the things I want to do is, build the next generation of computing in a world that's changing fast. So I'm not worried about the 800-pound gorillas because they don't move as fast.
Speaking of that,
Also,
sorry, go for
it's a
it.
fun thing.
Do you see other competitors in the RISC-V space as almost like teammates helping legitimize RISC-V, or do you see?
Yeah. Oh yeah, definitely. Yeah.
So like these.
Yeah, Rivas just got funding. Its company's run by a friend of mine. They got some really good designers. I wish them the best. Sci-Vive's a good company. Krista was one of the original pretty good Berkeley guys, as you pointed out, that helped build the RISC-V architecture. Andy's is a really great company. Their CEO's, he's a character. I really like him a lot. They're driving real stuff. I know the Ventana guys. Yeah, like the CPU market's huge.
Yeah.
Right. And to be honest, having 5. So x86 was the original open source architecture, right? They licensed it to like 6-7 companies. And the reason it built Z80, 6800, 6502 was because those were single source proprietary architectures, and x86, the original 8086, was open. Now it's become proprietary with two, duopoly, controlling it, but it was the open architecture. That's why it won. It didn't win because it was better. All those CPUs were crap, and small and arbitrary.
Speaking of there being
MIPS was way
only...
better.
Oh, okay. Speaking of there being only 2, we got our hands very recently, I'm about to tease an upcoming video here, on a Centaur processor that, it's obviously it never actually made its way to the market, but Centaur Halls, it's an 8-core, it's clocked at 2.5 gigahertz, and it seems to have risen out of the ashes of VIA.
Yeah, I haven't followed that for a while.
Well, no one's
cool.
followed it for a while. It's been dead for a while, but their concept was on CPU AI, kind of like what you just alluded to, that was very affordable. They were targeting $500 for this chip with on-chip AI, or with onto AI, and it just couldn't get over the line. Was the problem x86? Was the problem just they didn't have a good enough team? If you don't know much about it, that's totally fine. It just was, it was a funny coincidence that we made a video about it this week, and that you brought up that concept. Okay, so if you're not...
I don't know. It turns out, building AI hardware and software that works is harder than it looks, let's say. Like my friend Roger Kadori said, every AI company in the middle of it, there's a mole ad unit. And everybody can build one. But building, AI is complicated because it's a general purpose computer that runs AI programs. So you need all the layers. You can't just build an AI engine with a compiler that runs a couple benchmarks. There's firmware, there's drivers, there's security, there's interrupts, there's every single piece of it. And the thing we've been working on is elaborating out that full stack.
On that subject.
From top to bottom. And then the other is a lot of people tried to make a dent in the market with one chip, and it's relatively small.
So
to drive a car, it's going to be a couple petaflops.
To
run real-time video. We're building a computer which we think will run real-time video in a single box at a reasonable price, but it's expensive. It's a big AI engine. It's not a $500, 200 teraflop chip. It's pretty serious.
Okay, so let me jump in with what was going to be my next question from Ricky. Like you said, hey, it turns out AI, pretty hard. Driving a car, pretty hard. I mean, Mr. Musk has famously promised us that full autonomous driving is X amount of time away. I kind of am wondering if he had an early point in his career where he worked at Valve at this point when it comes to giving ETAs for things. And Ricky wanted me to ask you, okay, how far are we really away from full self-driving? Because I got to tell you, I am relatively speaking an idiot. But when we got the promise that, full self-driving was going to be...
Can you drive a car?
I can. Well, okay.
Oh, so you can...
At least I'm smarter than your computer.
So it doesn't seem like we don't really need AGI to drive cars, it turns out.
Okay, so...
it's pretty funny.
What I was trying to say is... Relatively speaking, I'm an idiot, but I looked at the claim that, every current Tesla was going to be capable of full autonomous driving. And I went, there's no way. There's no way. Even knowing what I know, it's just, there's absolutely no way that they have the kind of capabilities, even if I extrapolate, even if Tesla is 10x what everyone else is doing on the market right now. I'm sorry, I don't buy it. So Ricky asks me to ask, how far are we away from true, level 4, level 5, true full self-driving? Give me a spitball.
Well, my favorite crack about Elon is he turns the impossible into late, and then people complain about it like crazy. And I always thought that's pretty good.
Got to raise money somehow.
Yeah, well, sure. Kick the can down the road, build some products. Their cars are great. I have 2 of them. So, and I like full self-driving. I use it every day. And it's a little quirky, but it's getting better. So there's building a big enough AI engine. So humans drive cars really well. I taught both of my daughters in, a couple hours to drive a car. And it turns out they both have a general intelligence, right? And so for them,
congratulations,
driving is a subset of that. It's pretty good. And I was thinking of A/B testing them, like I was going to have one of them read the rules and then go for a drive, and then I was going to have the other one watch 100 million hours of video, and then see which one could drive faster. But my daughter Catherine, she told me to bug off. And she's like, no way I'm watching 100 million hours of video to learn to drive a car, Dad. She learned in 8 minutes flat. So the general intelligence seems to be a really good thing. Now, the problem in the cars today is we're trying to put a small AI engine there and get the maximum performance out of it.
Yeah.
So Waymo, I'm in San Francisco right now. They drive around with no drivers in the car, it's pretty spooky. And, that's a fairly heavy-handed solution because it's got a shitload of
Sensors everywhere, yeah.
Mosquitoes and all that stuff. Whereas Elon would say, like, a one-eyed guy with 2200 vision could drive a car, and, you don't have to be that smart. Now, that causes a trade-off because the smaller the computer, the better the software has to be. So I think if you put, 5 petaflops in a car with some of the new good transformer models, you could drive a car pretty fast. But there's another weird thing, which is humans aren't data intelligence. We're computationally intelligent. Like, you didn't get smart by watching hundreds of, millions of hours of anything.
Don't tell my audience that.
Yeah, well, maybe you watch hundreds of hours in the last week, but it's only, tens of thousands of hours. It's not that much information. Like, we get some information. We essentially learn to simulate the world. So, I don't know if we live in a simulation, but our brain sure is a simulation. And we haven't really cracked the AI problem of building really smart systems that like simulate themselves and essentially create intelligence with simulation. They're creating intelligence with data prediction, which seems pretty smart, but it doesn't seem like, it's not close to what we actually do.
I want to loop
back. There's arguments like, people get a lot of data from vision, but blind people are smart too. Like, you don't need to see anything to be smart, and that's not much data at all.
I want to loop back around to one of my earlier questions, and this is obviously going to be a little bit of crystal ball gazing, and I don't expect you to have a good answer for it. But I asked, okay, how much of a generational improvement is we just didn't think of that versus we just didn't have the capability? Right now, you're really focused on AI. You're focused on RISC-V. That much is very obvious. But I have to imagine, for someone like you, talking to the people you do talk to, you got to have some idea of what the next thing is. I mean, obviously, Jensen had some idea where he was going with CUDA, while everyone else was sitting there going, why don't I just have more FPS on my stupid gaming thing, right? What is there a RISC-V replacement that is two cells dividing right now? Where are we going?
Well, let's say it a different way. So your brain, there's this theory about you had a primitive brain, then a motor cortex, and then an emotional brain, and then cerebral cortex. So our brain evolved to add layers. Like, our cerebral cortex is essentially a high-end planning machine. And so obviously animals survived just fine without one. And then when it started to grow, you have to ask, like, what was it for? And it could be it helped model the world better and create better planning with better outcomes. And at some point, the cerebral cortex took over. Most people think they live there in their head. So you can do things really fast with direct connections through your motor cortex. But most of the you that you believe is you, if you believe in that kind of thing, seems to be your thought process in your higher level thinking. So today, AI computers are treated as accelerators to general purpose computation. That's going to flip pretty soon. AI computers are going to treat general purpose computers like a motor cortex. So there'll be AI things running to do stuff, and occasionally they'll say, generate a deterministic program to do something, right? As opposed to deterministic programs calling up AI modules. So that flip is coming pretty fast. And
interesting.
The way we think about programming, like you were talking about, well, how are we going to run the old games? None of that's going to exist. Like, and even stuff as simple as video is going to be all generated. Like, nobody's in 10 years going to watch a movie. Like, you're going to live in a movie, right? It's going to be all real-time generated, and you're going to interact with it. And you're going to ask your favorite character, what the hell's going on? They go, shut up, I'm shooting somebody. Like this is going to happen faster than you think. And so all the mediums we think about are toast, and all the software that's ever been written is going to be gone, like 100%.
I mean, obviously, there's going to be a ton of resistance to this.
I mean, there'll be a guy with a rotary phone and an iPhone and a Java program or something, it won't be material to your everyday life.
So, okay, I guess I'm about to ask you to, and feel free to ignore this question if you're just like, look, I don't need the,
I
I
have
don't need
one
the
more
hate
if
mail.
you want it. So, yeah, I'm a believer in we're gonna we're gonna use AI to rethink a lot of science. And,
Right.
so human beings, like we have this idea of like, you get data, you have a theory, you have a prediction. The problem is you get trapped in your theories. And so then new data comes along and you can't really interpret it into your theories. So all our science is it's elaborated from a bunch of ideas, but they're all human ideas and they can't encompass all the data. And I think science is going to go through a fairly big revolution.
I'm still going to see if I can get a hot take out of you. When
Okay,
you
cool.
see, for example, you see I think you've brought up entertainment a couple times. You brought up gaming, you brought up film. When you see, for example, the Actors Union negotiating to keep generative AI out of film and music, out of art, what's your take on that?
This has happened a lot. There was a big split, supposedly in Europe. I read it in the history books that, Austria banned like knitting, weaving machines and clothing mills and all that stuff because they didn't want the people to lose all their jobs. And England embraced it, and one won and one lost. So, yeah. So the writers' unions will say you can't use this for this movie. And it'll create a whole new area where they don't exist, and people will generate all kinds of stuff. And so technology change usually means you get on board, you get left behind. Now I think there'll still be writers, there'll still be books, there'll still be movies made by people for people. There's all kinds of stuff like that. Like you can buy machine-made clothing, but people buy knitted clothing. People like what people do. And that's a really great thing. We like artists. Like you can get a perfect painting by somebody printed, but you still buy the painting from the artist that you talk to because it's at some level more interesting. But yeah, keeping AI out of this and that and the other thing is going to be a hard fail.
I want the last sort of big one. I know you should probably. I think we've kept you longer than we said we would. I'm very sorry for that, but I promise we're getting close to the end. We haven't talked about atomic semi at all, and this time I'm coming in without having done any pre-briefing because like I said, it kind of slipped under my radar. You say you're focused.
I'm at the office. That's an atom.
Okay, I didn't know it was an atom, but is that the logo? Is that the logo for the company, or okay, cool.
Yeah.
So. All I know is you guys are working on low-cost fabrication equipment. Like when you say fabrication equipment, you mean like ASML fabrication equipment? What are we talking about here?
But smaller. Like a little tiny one like that.
So you want to what your wafer is like 5 centimeters or why? Tell me about that. Okay, even smaller. Help me.
So the semiconductor technology is great today, and all the equipment is great.
Yeah.
And it got optimized to make very large wafers that move very fast.
Yes.
Right. They're 12 inches around. Like the thing that holds it weighs 50 kilograms and it moves. So if you look at all the machines, it's really hard to build and heavy and all kinds of stuff.
Yeah, you got to account for seismic stability of the land, make sure there's no ancient burial grounds under it, that sort of thing. Yeah.
It's amazing, right? So I met this kid, Sam Zulu. Like he made a fab in his garage in high school. He has YouTube videos about it, and then I met him when he was in college, and we started talking about what it would mean to go build a set of equipment where you could make a fairly high-tech chip really fast, but just make one chip at a time. And then optimize the crap out of it because you're not solving the problem of moving 50 kilograms at 100 miles an hour. You're not trying to keep something perfectly flat over a huge surface. Like basically change the game and make something way, way simpler. And then take advantage of, like there's hundreds of billions of dollars of material research being done. You can deposit atomic layers of almost any material, single atom at a time. It's beautiful.
So is the goal to be
We
like?
decided to go.
Sorry, go for it.
Well, my personal goal is to go make a really interesting chip really fast. And
It feels like the 3D printing.
Like one of our investors
prototyping.
said, it's basically 3D printing.
Compared to injection molding, right?
Yeah.
Where you don't have to deal with the enormous scale. Huh.
Yeah. Now the weird thing is, if you make them fast enough, it could be for more than prototyping.
Right, which
But
also happened with 3D
it's-
printing.
This is, yeah. Well, 3D printing is amazing, and it just keeps getting better and better and goes into more stuff. And then there's really fun stuff like you 3D print molds and then injection mold that. Like what you can do today with the combination of modern CAD tools, 3D printing, injection molding, and then CNCing and all kinds of stuff. It's fantastic. And yeah, so we're into building our own machines that make chips, and using an unbelievable amount of material science research. They publish everything. You can buy any atomic layer deposition material you want for almost nothing. It's crazy. Yeah, it's super fun.
Okay. Which I mean, this is it's almost like a chicken egg question, right? Like which comes first for you in terms of taking Tenstorrent to the next level, in terms of taking Atomic Semi to the next level? Do they drive each other? Like, is this an attempt to be
Maybe someday.
real men own fabs? As the famous quote, right?
Yeah,
Like,
I have a fab.
is that
I have
the
a
goal?
computer design company. I have AI software. Sure.
Why not? Right?
Yeah, why not? What are you doing this? I mean, like a lot of people are like, what are you up to? It's like
Damn!
Boom, roasted. I make
I
YouTube
know.
videos.
It's like people, hey, this planet might get hit by an asteroid or blown up by a volcano, man. I want to make sure that gets stopped. I'm hustling. Elon's
right.
like, get a backup planet, but we got big problems right here. So yeah, we got to get moving.
All right. Well, on that note, I think this is a perfect time for us to say thank you so much for coming on the show. Preemptively, I'd like to get out there and make it so that you can't say no because it's in front of 10,000 people, and say we'd love to have you on again sometime. I know that Tenstorrent has some really cool stuff coming, and we'd love to take a look at it once that's a little more baked and once you guys are ready to kind of engage with us, do some videos together. We'd love to maybe have you come on for a deeper look at the normie version that we publish on the main channel. Maybe we can have a chat about it after.
This was the normie version.
This is the really
The weirdo
dialed in
version.
audience.
Nice.
Yeah, this is
Okay.
this is the guys that'll
great.
sit and listen to us for 4 hours a week. This is the WAN show. So, guys, if you could just give us some applause in the chat for Mr. Jim Keller. Really appreciate you taking this time on a Friday night. Get to your family, please, sir, and hope to talk again soon.
Okay, great. Hey, great talking with you guys.
All right, thank you.
Thank you very much. That was great.
All right.
Oh,
Maybe we should do interviews more.
man.
That was a lot of fun.
And I knew from watching some of his other interviews that his answers to things were going to be extensive, but I was like, I want to make sure I'm prepared. So I had all these questions. We got through, I don't know, a 20th of what I wanted to talk about. And we didn't get through almost any of those. And then you had your own. It's just like,
That's why I preempted.
man.
That's why I got out ahead of it, because
How
I
much
knew you
time-
had
yeah,
stuff.
yeah.
And his staff told me, because I was like, look, realistically, we don't want to take up a ton of his time.
Yeah,
we don't want
I do now.
we don't want the WAN show to be 9 hours long.
I do now.
Could we maybe schedule? Could we maybe ask him for 20 minutes? Because I wanted to be super reasonable, and they were like, I'll tell you what.
You don't want that.
We'll put 20 minutes on the thing, but we're gonna tell Jim some other amount of time that's longer, because people get talking to Jim and then, I mean, is time even real anyway?
Yeah.
That was so much fun. Obviously, we do have to move on into our next topic. That was a blast.
That could have gone on forever, I think.